Hello everyone, I have here the formula for the compound interest. It's A equals P times the quantity 1 plus R divided by N raised to the exponent N times T. Okay, so A is the final value or the final amount after T years. P is the principal amount or the initial principal balance. R is the annual interest rate expressed as a decimal. N is the number of compounding periods per year. T is the time in years. Okay, so suppose that I am solving a word problem involving compound interest and I am required to find the annual interest rate or R. What should be my formula to find the missing R? So that is the subject of this video. I am going to tutor you on how to derive the formula when R is missing. Let's start. So this is the general formula for compound interest. A equals P times the quantity 1 plus R divided by N raised to the exponent N times T. My goal is to gradually isolate R by itself on the right side. So the first variable that I'm going to remove from the right side is P. Since P is being multiplied to the exponential part on the right side, I'm going to eliminate it using division. Divide both sides by P. A divided by P, and the right side divided by P. Okay, so P is eliminated from the right side. The right side becomes the exponential expression. 1 plus R divided by N, grouped together, raised to the exponent N times T. Okay. Next, I want to bring down the exponent N times T. So to be able to do that, I'll use rules for logarithm. So I'll take the logarithm of both sides and I'll choose the natural logarithm. You can also choose the common logarithm. Common logarithm is base 10 logarithm, while natural logarithm is base e logarithm. So you can choose either of the two logarithms. I'll use the natural logarithm. So I'll take ln of the left side and also the ln of the right side. Next, on the left side, I'll use the quotient rule for logarithms to expand the left side. What's the quotient rule for logarithms? It says that the logarithm of a quotient can also be written as the difference between the logarithms. So ln of A over P can be written as ln of A minus ln of P. So this is the expanded form of the logarithm of the quotient. On the right side, I'll use the power rule for logarithm in order to bring down the exponent, because the power rule for logarithm says that The logarithm of a power can also be written as the product of the exponent and the logarithm of the base. So that is nt multiplied by the logarithm of 1 plus r over n. Okay? Next, I want to remove nt from the right side. So since it's being multiplied to the logarithmic expression, I'll use division to eliminate nt. Divide both sides by nt. Okay, so left side becomes ln of A minus ln of P divided by n times t. And the right side becomes ln of the quantity 1 plus r divided by n. Next, I want to eliminate ln from the right side. Ln is logarithm to base e. The natural number e. Okay? So, to remove this from the right side, I'll put base e to both sides of the equation. Because it's the base e that will cancel out the ln on the right side. Okay, so on the left side, we now have e raised to ln of A minus ln of P over n times t. And the right side becomes 1 plus r divided by n. Okay, the next step is to eliminate 1 from the right side. I'll use the inverse operation of addition to remove it from the right side. So, subtract 1 from both sides of the equation. Okay, so your right side becomes r divided by n. And the left side becomes e raised to ln of A minus ln of P divided by n times t minus 1. And the last step is to eliminate the denominator n from the right side. The operation between r and n is division, so I'll use the inverse operation of division to remove n from the right. And that is multiplication. I'll multiply both sides by n. So the denominator is cleared. On the right side, r is isolated. So this is the derived formula for r, and you can use this to solve for the missing r when n, a, p, and t are all given. Okay, so if you have questions or you want clarification, use the comment box. Please don't forget to subscribe to my YouTube channel. It's Tutor Marife MCP. Thank you for watching.